All right, let's look at how to find the cumulative distribution function of a discrete random variable. Um, the key point is that you need, we need to pay attention to the word cumulative, or just the definition of what it means. So let's first just calculate a few examples, because what we are doing is that we are trying to find capital F of t. So let's look at, say, what f of the negative 2 is going to be, because t has to be between negative infinity and the positive infinity. So if you look at this one over here, it means you're trying to find the probability of this the random variable is less than or equal to negative 2. Now, look at the table. The only possible values for capital X is negative 2, 0, and 1, and 2. So there is no chance this capital X is going to be less than or equal to negative 2. So this probability is simply going to be 0. Now, let's try another example over here. Let's try to see what's going to happen if we want to find the value of f of negative 1. And this is going to be the probability of x less than or equal to negative 1. Now we know there's only one possibility for this to happen, is when x is actually negative 1, and the probability is 0.2. So this one over here is equal to 0.2. Now let's try another one so we can see the meaning of the word cumulative. So let's look at, say, what's going to be the value of capital F of, say, 0.5. And this one means it's the probability of capital X is less than or equal to 0.5. And then you see there are two chances. One is when that x is equal to negative 1. Okay? And because negative 1 and 0 are two different points, so we can actually see this is the probability that capital X can be less than or equal to 0.5. And then we will have 0.2 plus 0.2, and that's going to be 0.4. And hope that's enough. And then we are going to find this capital F of t for all values of t. Of course, we cannot possibly do this by one. So the easiest way actually is to draw a diagram to help us. So we will do this. Okay, so this is going to be capital F of t. Okay, and here we will have the value t over here. And we will plot those values of capital X on the t-axis. So here is negative 1. Okay. And then here is 0. And here is 1. And here we have 2. So these are the values that capital X, this random variable, can take. And then we will try to actually sketch the diagram over here. So there is no chance for capital X to be less than negative 1. So the probability over here is simply going to be 0. Let me choose a different color. So this is the graph we have. This is the open circle. And then between negative 1 and 0, we have probability over here, positive 0.2. And here is again an open circle. And this point over here is 0.2. It says it doesn't matter where t is located. So what it means is that if t is between negative 1 and 0 exclusive over here, then your f of t is going to be simply 0.2. Or you can see this. What it means is that if um, if t is between negative 1 and 0, then the probability of capital X is less than or equal to t, it's precisely the probability of X is equal to -1. And that's 0.2. And by the same reason, if your t is between 0 and 1, 0 inclusive, but 1 is exclusive, and then we will have value over here, 0.4, and we have this one. Okay. And then between 1 and 2, we are going to have 0.8. And after 2, we will have 1. And here is 1. Okay. And here is 0.8. And here is 0.4. So we can write down this capital f of t as a piecewise function f of t. And we have over here that if t is less than -1, the value is going to be 0. If t is less than 0 and bigger than or equal to -1, that's 0.2. And if t is less than 1, bigger than or equal to 0, that's going to be 0.4. And if t is less than 2, bigger than or equal to 1, we have 0.8. And then if t is bigger than or equal to 2, it's 1. And that's always the case for a discrete random variable. Its cumulative distribution function is piecewise constant, continuous from the right. And if we look at over here, it is continuous from the right, and there is a gap. This gap is exactly the probability of X taking value 2 over here.